Guys, so we're going to go on and finish up the review sheet. So we've got about halfway through this on Friday, Thursday. Yeah, Wednesday. So these are the ones we finished up with for solving these here. Now we worked through these by hand, but we also saw that the yellow calculators will solve these for us also. Yep. For all the ones that will have the graphing or not the graphing, but the yellow, the TI-30XS will do these. The only stipulation is if the numbers get too big, but for most of the ones we'll look at and cover, they won't. Like 1 through, what is that? The first page, yes. Now the next group that we have are 25 through 30, but those won't come up or show up on the test. So the next one we want to look at is number 32. Number 32. Now 31 and 32 are talking about our addition, subtraction, multiplication, and division of our functions. So the first one we're looking at is f plus g of x. Now our f plus g of x is the same as saying f of x plus g of x. We're just adding the two functions together. Now f of x for this function here sold to us is 4x to the 5/4 plus g of x, which is 2x to the 1/2. So far, really we just kind of broke it down. F plus g of x is the same as f of x plus g of x. And then we went on and replaced f of x and g of x. Our f of x is 4 times x to the 5/4, and g of x is 2 times x to the 1/2. Now we can add these together if the variables are the same. Is x to the 5/4 the same as x to the 1/2? No. That's it. Because really we're saying here 4x the 4th root of x plus 2 times square root of x. Those are not the same. Those are not the same in any way, shape, or form. So we can't actually add them together. Because the only way that we can add them is if it would have been x to the 1/2 and x to the 1/2. If those variables had the same exponent, then we can go on and add them. Now, our next one is f minus g of x. So this here would be f of x minus g of x. And if we put the functions back in, that'd be 4x to the 5/4 minus 2x to the 1/2. Now, if we couldn't add the functions, can we subtract them? No. Any questions on addition or subtraction? Let's look at multiplication. F times g of x. Well, this is the same as saying f of x times g of x. And again, just like the ones before, we'll replace f of x with its function, 4 times x to the 5/4. And it's being multiplied by 2x to the 1/2. Now we multiply these two functions here. We can multiply the 4 and 2. 4 times 2 is 8. Now when we multiply like bases, because x and x are the same, we add the exponents. So we're going to be taking 5/4 plus 1/2. Now the 5/4 plus 1/2, we can do that in a calculator. And we were going to leave it as a fraction. We don't want it as a decimal. This will give us 4ths, 7/4. So for our multiplication, we have 8x to the 7/4. And that would be it. Any questions on this here? Now the last one we have is division. which is our f divided by g of x. Now for us here, this is just saying that we're taking f of x and dividing it by g of x. Well, our f of x is 4x to the 5/4. G of x is 2x to the 1/2. Now at this point here, we can go on and simplify. 4 divided by 2 is 2. And when we have like bases being divided, we subtract the exponents. So we'd have 5/4 minus 1/2. And just like with the multiplication, we can plug this subtraction, 5/4 minus 1/2, into the calculator to get our answer, and it should be 3/4. So with these here, when we're doing these with addition, subtraction, multiplication, division, if you get a problem like this on the test tomorrow where the exponents are different, the addition and subtraction aren't going to be able to combine. We're going to end up with 2 terms. But with multiplication and division, we should end up with 1. Any other questions on this here? All right. Let's look at these are not on the test, where we're plugging in for the given value. All right. So the next thing we're going to look at is our composite functions. Which one do we want to look at? 35. So f of g of x. And with any of these here, we work from the inside out. So the first thing we have is f of g of x. For us here, what is g of x? So I'm going to replace g of x with negative 2x plus 5. Because we essentially plugged in x4 into g of x, which gives us negative 2x plus 5. Now what we're going to do next is going to take the negative 2x plus 5 and plug it into f of x. So every place there's an x in f of x, we're going to replace that x with negative 2x plus 5. So for f of x, we have 7 times x, but we're replacing the x with negative 2x plus 5, close parentheses, minus 2. Now we just need to simplify this. So 7 times negative 2x is going to be negative 14x, plus 7 times 5 is 35 minus 2. So what we get is negative 14x plus 33. And that's all we have to do for this here. Any other questions on 35, 36, 37, or 38? Okay. Anyone in particular? We can do 37. So f of x now our f of x function, if we plug it in, is 7x minus 2. So if I replace the 7x, the one in the middle, one inside, with what it is, it's going to be f of 7x minus 2. Now at this point here, we're taking f of 7x minus 2, yes? So that means I'm going to replace every x in f of x with 7x minus 2. So what that would give us is 7 times 7x minus 2 minus 2. So it really doesn't matter what we're doing. We can do it with any of these here. It's just we're working from the inside out. So we started with f of x, which was 7x minus 2. Then we took f of 7x minus 2. So plug that in for x. And now we're going to simplify. Well, 7 times 7x is 49x. 7 times negative 2 would be negative 14. And then we have the minus 2, which would give us x minus 16. And that's all we have to do for this here. Any other questions on any of these here? (41). 7x minus 2. And then our other function was negative 2x plus 5. Our f of x and g of x. Yes. And this one here is actually a lot easier than what you think it is. Because again, with all of these here, we work from the inside out. So if we look at this here, so we have g of f of g of f. And the farthest in is g of 3, yes? So we're going to plug 3 into g of the x in g of x, which would be negative 2 times 3 plus 5. 2, 3, 4. Well, I can do negative 2 times 3 plus 5 in a calculator, yes? Which would be? So it'd be negative 2 times 3 is negative 6. Plus 5 is, so we get negative 1. And we could do that in a calculator, negative 2 times 3 plus 5, and get negative 1. So now what do I have? I have f of, so we still have the g, f, g, but now f of negative 1, we're plugging negative 1 into our 7 times x minus 2, which would be 7 times negative 1 minus 2. Well, again, can I do 7 times negative 1 minus 2 in the calculator? Yes, 7 times negative 1 is negative 7. Minus 2 is negative 9. Guess what we're going to do next? Take g of x, g of negative 9, which would be our negative 2 times negative 9 plus 5. Or can we plug in negative 2 times negative 9 plus 5 in the calculator? Okay. If we do that, negative 2 times negative 9 is positive 18. Plus 5 is now we're plugging 23 into f of x, which would be 7 times 23. Is it plus 5 or minus 5? Minus 2. I'm thinking of the other one. But again, 7 times 23 minus 2. We can just plug that into the calculator. And this would give us $159. So now we have g of 159, yes? So we're going to plug 159 into g of x, which would be negative 2 times 159 plus 5. And again, at this point, we just type that in. And if we type the whole thing in, we get 313. And that'd be the final answer. So it's not that this one's difficult, we just have, it's just long, because we're just plugging that first number in to the first function, then plugging that into the other. But again, on any of these here with the composite function, start from the inside and work your way out. So work it one at a time. Any other questions on this here? We'll come back to finding inverse, because the main part I want to look at is solving these here. We can look at 44 first, because whenever we solve these radical equations, the first main step was to get the radical by itself. So with 44, is the radical by itself? Yeah, because if we look at the square root of 2y, there's nothing in front of it being multiplied by the square root. There's nothing added or subtracted to it. So the radical is by itself. That's the first main step. Our second main step is to put both sides to the nth power. We want to match up the root. So since it's a square root, we're going to square both sides. Because here the square root and square will cancel, telling us 2y is equal to 64. And then the last main step was to solve for the variable. So here we would divide by 2, y equals 32. And that's it. Now, most likely, there are some we have to check, but again, if you're paying attention to the instructions, it's going to be, I'm going to emphasize that you need to check your answers on some of them. This is a majority of the test, is solving. Solving is a majority of the test. Mm-hmm. Questions on 44? Questions on 45? Any questions on 45? Questions on 46 or 47? Okay, so we would cube it, which would tell us that 2x minus 1 is equal to 8. Add 1 to both sides, telling us 2x is equal to 9. Divide by 2 tells us x is equal to 9 over 2. Questions on 46? So 46, the first thing we need to do is to get the square root by itself. So the first thing we can do is subtract 27 from both sides, which will tell us that 3 times the square root of 2x plus 7 is equal to negative 23. Then we would divide by 3, which tells us that the square root of 2x plus 7 is equal to, and then what would we do next? Because anything that comes out of a square root has to be positive. It has to be positive. Because again, when we're looking at these here, we're trying to find the real solutions. Because the only way, there's really no way to get a negative out of a square root. Because again, when we talked about square roots and squares with quadratics back in the fall, when we're looking for a number times itself to give us when we talk about square roots, here we're trying to say what number times itself, or what is the number that multiplied by itself gives us this negative. Essentially, we're saying if I take the square root of 16, how can I get negative 4? Well, we can't. Because negative 4 times negative 4 is positive 16. It can't work the other way around. This is when we start dealing with imaginary numbers. Now, you can go on and square both sides and solve it, but if you plug it back in, it won't work. No solutions are not going to show up on the test. I'm not going to throw a no solution on the test. There will be some where one of the two solutions doesn't work, but I won't have one where both don't work. I don't like those on the test. I'll throw them on the review sheet, but I won't throw them on the test. Any other questions on 46 or 47? Next page. Questions on 48 or 49? Yes. So when we talked about these here, we went through, and our first kind of main step was to get the radical by itself. Then we kind of added a subclause. If there's more than one radical, even them out. We want to try to even them out. So what can we do to even this one out? Add the 9th root of 4x to both sides, yes? If I was working this here, I would mark out that 0. Because again, when we add it to both sides, they're both going to be positive and on opposite sides of the equal sign. Because what we're doing, you don't have to write this back in, is adding the 9th root of 4x to both sides, which just tells us that we have the 9th root of 2x minus 1 is equal to the 9th root of 4x. Because when I work these here, I kind of mark the 0 out and say, hey, they are equal, and we're good. We can do this even if they were added. We can put an equal sign and just leave the negative. Okay, now we need to apply the 9th root, or the 9th power to both sides. Well, the one on the left, the 9th root and 9th power cancel. On the right, the 9th root and 9th power cancel, telling us that 2x minus 1 is equal to 4x. Now we just need to solve for the value of x. So what can we do first? Subtract the 2x from both sides, if it'll let me, which will tell us that negative 1 is equal to, and then we would divide by 2. X is equal to negative 1/2. And this works because, again, we can't have negative numbers inside even roots. Are we dealing with even roots for this problem? No, 9 is an odd root. We can take the odd root of a negative number. We can't take the even root of a negative number. So x equals negative 1/2 does work for this here. Any questions on any of this here? Questions on 49? No. And again, this works because I can take the odd root of a negative and get negative 5. Because the cubed root of negative 125 is negative 5. So we can do that. Because I can't take the square root of negative 25 and get negative 5. It just doesn't work. Questions on 50 or 51? 50 is a little different because we do have a variable on the outside. This is going to be one where you will need to check our solutions. So first step is to get the radical by itself. Is it by itself? Okay. So now we need to square both sides. And if we square both sides, well, on the left-hand side, square and square cancel, telling us that we have 3 minus s is equal to, well, s minus 1 squared is going to be s minus 1 times s minus 1. Now we need to use the distributive property on our s minus 1 times s minus 1. So that we have 3 minus s. S times s is s squared minus s minus s minus, wouldn't be minus, would be plus 1. Because s times negative 1 would be negative s. Negative 1 times s would be negative s. And negative 1 times negative 1 is going to be plus 1. And once we combine like terms, we're going to say 3 minus s is equal to s squared minus 2s plus 1. Okay, now we need to get everything on the same side because we do have a quadratic. So we can subtract 3 from both sides and add s. Because doing that would give us 0 is equal to s squared minus s minus 2. Because we'll have to subtract 3 and add s. Because again, if we have a variable with an exponent greater than 1, so 2 or greater, we have to get it equal to 0. Now at this point here, we can graph it to see where this graph crosses the x-axis, or we can factor it. Now if we factor this, since the 2 is negative, our signs are opposite. Factors of s squared are s and s. The factors of 2 are 1 and 2. Which one needs to be negative? The 2. And these would be our factors. And anytime we have 2 or more things multiplied together to equal 0, one of them has to be 0. So either s plus 1 is 0 or s minus 2 is 0. So either s is equal to -1 or s is equal to 2. S. Now again, this is going to be in one of the ones in the section. The instructions are going to literally say, I think in all caps, check your solutions as part of the instructions. Because if we check this here, square root of 3 minus -1 is equal to -1 minus 1. Well, 3 minus -1 is 4, square root of 4 is 2. -1 minus 1 is, we can say that 2 is not the same as -2. So, s equals -1 does not work. S equals 2. Square root of 3 minus 2 is equal to 2 minus 1. Well, 3 minus 2 is 1, square root of 1 is 1, that works. For checking, as long as you give me this and this, this and this, we're good. Because again, we could have plugged that whole thing in the calculator. Because you could have grabbed the calculator, taken the square root of 3 minus -1, hit enter, and it would have told you that it's 2. And you could have done -1 minus 1 is -2, gone from here to here, said, okay, they don't work. Here to here, okay, they do. Because if it says check, I am including a point, at least a point, for you checking to make sure that they work or not. So I will, on the ones that say check your answer, I am giving you all points if you check it or don't. So if you don't check it, I'm going to automatically deduct a point there. Easiest points on the test besides the ones you just plug in. Any other questions on this here? This one is not showing up as a bonus. I know that for sure. Any other questions on any of this here? Questions on 54 or 55? The inverse. This is the last thing we'll look at, is determining if they're, I'm not going to have you find inverses, but there is going to be a bonus for determining if the following functions are inverses. And they are, but to find it, to get full marks for the bonus, you'll need to find f of g of x and g of f of x, our composite functions that we did before. And if they are inverses, both of these should end up being x when we finish them out. Now, if we look at this one here, f of g of x, well, g of x in our case is 4 minus x over, or x minus 4 over 6. So just like what we did before with our composite functions, we plug in g of x for what it is. Now at this point here, we're going to plug this into f of x, which will tell us that it's 6 times x minus 4 over 6. This should be plus 4. Determine if the following. So these here aren't inverses, but I'm going to switch it to plus so that we can see this. Because if we do this multiplication, well, the 6 and 6 will cancel, telling us that we had x minus 4 plus 4 gives us x. Because if we'd left it as minus 4, it would have been x minus 8, which would immediately told us that no, these are not inverses. But if it was plus, we would get x. Now the other one is going to be g of f of x. Now our f of x is our 6x plus 4. And if we plug this into g of x, it would be 6x plus 4 minus 4 over 6. Well, plus 4 minus 4 is 0, which would give us 6x over 6, which is x. Okay, we've shown that these two are inverses. And that's it. Any other questions on this here? And that will be the Chapter 5 test tomorrow.